we shall do additional problems on energy density and energy stored. First problem is find the energy stored in a sphere of radius equal to a, in which the charges are uniformly distributed. Charges are uniformly distributed with a density rho v coulombs per meter cube. Very frequently asked problem in the examination. Find energy stored in a sphere of radius equal to a, in which charges are uniformly distributed, the density rho v coulombs per meter cube. Solution. Concept. Formula for energy stored is W is equal to half into volume integral vector d dot E dV. Half into volume integral vector d dot E dV, where V is the volume, that contains electric field intensity, that contains vector E. Now I'll take a sphere of radius equal to a. Charges are uniformly distributed inside the sphere with a density rho v coulombs per meter cube. Now electric field intensity is present inside the sphere as well as outside the sphere. Therefore, we have to find energy stored inside the sphere and energy stored outside the sphere. Then we have to add these two energies to get the total energy stored in the system. In the last class, I did a problem in which charges were residing only on the surface of the conducting sphere. Here, there is no electric field intensity inside the sphere because charges are residing only on the outer surface. That means, in other words, we have to find electric field intensity outside the sphere by using Gauss law, and then we have to use this expression to find the energy stored. That's what I have done in that problem. You can please check. Now this is the sphere. The dotted sphere represents the Gaussian surface. GS is the abbreviation for Gaussian surface. P is the point of interest. R is the radius of the Gaussian surface. P is the point of interest. If you keep 1 coulomb charge at point P, it will be repelled because this sphere is positively charged, the density rho v coulombs per meter cube. Vector d is the radial direction. Vector d is equal to dr into ar cap. These are the sample flux lines coming out of the Gaussian surface. So case 1, r greater than equal to a. Step number 1. According to Gauss law, electric flux psi is equal to charge enclosed is equal to volume integral rho v dV. Now, the Gaussian surface encloses the charge contained by this entire sphere. This implies psi is equal to volume integral is a triple integral. R varies from 0 to a. Theta varies from 0 to pi. Phi varies from 0 to 2 pi rho v. What is dV? dV is r square sin theta dr d theta d phi. In a spherical coordinate system, please note that dl1 is equal to dr, dl2 is equal to r into d theta, dl3 is equal to r into sine theta into d phi. dv is the product of dl1, dl2 and dl3. Now we shall integrate this. Psi is equal to rho v. R square, if you integrate, you get r cube by 3 between 0 and a. Sin theta, if you integrate, you get minus cos theta between 0 and pi. D phi, if you integrate, you get phi between 0 and 2 pi. So this implies psi is equal to rho v into 4 pi by 3 a cube. So many coulombs. This is the charge contained by the Gaussian surface. Please don't integrate from r equal to 0 to r because there is no charge in this region. Charge is contained only for r varying from 0 to a. Please keep this point in mind. This is the charge contained by or charge enclosed by the Gaussian surface, which is a sphere of radius equal to r. Step number 2. To find vector D at point P. We know that psi is equal to closed surface integral vector D dot ds. This implies psi is equal to surface integral, the double integral. Theta varies from 0 to pi. Phi varies from 0 to 2 pi. What is vector D? dr into ar cap. What is vector ds? dsr into ar cap. What is dsr? dl2 into dl3. This implies psi is equal to dr. Theta varies from 0 to pi. Phi varies from 0 to 2 pi. R square sine theta d theta d phi. So this implies psi is equal to dr into r square. Sine theta, if you integrate, you get minus cos theta between 0 and pi. D phi, if you integrate, you get phi between 0 and 2 pi. So this implies psi is equal to dr into 4 pi r square. What is 4 pi r square? 4 pi r square is nothing but surface area of the Gaussian surface, which is a sphere of radius equal to r. This in turn implies dr is equal to psi divided by 4 pi r square. Unit of dr is coulombs per meter square. Hence, vector D is equal to dr into er cap is equal to psi divided by 4 pi r square into er cap. In step number 1, what is psi? Rho v into 4 pi by 3 into a cube divided by 4 pi r square into ar cap equals. So 4 pi cancels, you get rho v into a cube divided by 3 r square into ar cap. So many coulombs per meter square. This is the electric flux density at point P. It is in the radial direction, which is indicated by the unit vector ar cap. Step number 3, to find vector E at point P. We know that vector D is equal to epsilon into vector E. This implies vector E is equal to vector D divided by epsilon. So what is vector D? This is the relation rho v into a cube divided by 3 epsilon into r square, A r cap. So many volts per meter. Epsilon is what? Epsilon naught into epsilon r. Epsilon r is 1 if point P is in free space or air. So rho v into a cube by 3 epsilon r square A r cap volts per meter. Fourth step, to find energy stored. To find energy stored outside the sphere. So you may be wondering how energy can be stored outside the sphere. Energy is stored outside the sphere because electric field intensity exists outside the sphere. Physically, there will be capacitance formed between the sphere and the ground. Ground means R equal to infinity. In that capacitor, energy will be stored. That is the energy stored in the sphere for R greater than or equal to A. What is the formula? W is equal to, what is the formula? W is equal to half into volume integral vector d dot E dV. So what is this volume? This is the volume that contains the electric field. So this is nothing but half into volume integral. What is vector D? Vector D is rho v into A cube by 3r square A r cap dot. What is vector E? Rho v into A cube divided by 3 epsilon r square A r cap dV. A r cap dot A r cap is what? 1. So this implies W, this energy stored outside, therefore I will write WO. WO means outside, is equal to rho v into rho v is rho v square. A to the power 3 into A to the power 3 is A to the power 6 divided by 3 into 3, 9. 9 into 2 is 18 epsilon. Volume integral is a triple integral. Outside the sphere means R varies from A to infinity. Infinity means earth or ground physically. Theta varies from 0 to pi. Phi varies from 0 to 2 pi. 1 by r square into 1 by r square is 1 by r to the power 4. What is dV? dV is r square sine theta dr d theta d phi. This implies W naught is equal to rho v square into 8 to the power 6 by 18 epsilon. R square by r to the power 4 means 1 by r square. 1 by r square, if you integrate, you get minus 1 by r between A and infinity. Sin theta, if you integrate, you get minus cos theta with 0 and pi. D phi, if you integrate, you get phi between 0 and 2 pi. So this implies W naught is equal to rho v square A to the power 6 by 18 epsilon. 1 by infinity is 0. Then put the lower limit, you get 1 by A. This gives 2. The other bracket gives 2 pi. So this becomes now 4 pi A to the power 5, 4 pi A to the power 5 rho v square divided by 18 epsilon. 4 pi rho v square A to the power 5 by 18 epsilon. So many joules. This is the energy stored outside the sphere. Please check the calculations. Case 2. Case 2, R less than A. This is the sphere of radius equal to A. Charge density rho v coulombs per meter cube. This is the Gaussian surface. which is a sphere of radius equal to r. This is the point on the Gaussian surface. This is the Gaussian surface. At point P, vector D is given by dr into ar cap. These are the sample flux lines that are coming out of the Gaussian surface. GS is the abbreviation for Gaussian surface. Step number 1. According to Gauss law, electric flux psi is equal to charge enclosed. Now, charge enclosed by the Gaussian surface is a charge within this volume. So, this is nothing but half into volume integral rho v dv. Now, r should vary from 0 to r. Very important. Not 0 to a. Because we want what is the charge enclosed inside this dotted sphere. This implies psi is equal to half into volume integral r varies from 0 to r. Theta varies from 0 to pi. Phi varies from 0 to 2 pi rho v. What is dv? dv is r square sine theta dr d theta d phi. This implies psi is equal to rho v divided by 2. R square, if you integrate, you get r cube by 3 between 0 and r. Sin theta, if you integrate, you get minus cos theta between the limits 0 and pi. D phi, if you integrate, you get phi between 0 and 2 pi. So this implies psi is equal to rho v into 4 pi by 3. 4 pi by, this is, sorry, I made a mistake here. There is no half here. There is no half. Because Q is equal to, psi is equal to Q enclosed. Q enclosed is nothing but volume integral rho v dv. There is no half here. I had made a mistake. Please correct it. There is no reason why that half should come. So now this is psi is equal to rho v 4 pi by 3 r cube. How I got to know that I did that mistake is, I should get 4 pi by 3 into r cube here, because that is the volume of the Gaussian sphere. So if half is there, then it becomes 2 pi by 3 into r cube, which is not the volume of the Gaussian sphere. Therefore, something wrong was done, which I corrected. There is no half over here. Please understand. So 4 pi by 3 into r cube is nothing but the volume of the Gaussian sphere. This is nothing but volume of the Gaussian sphere or Gaussian surface. Okay. This is step number 1. Step number 2. To find vector D at point P. We know that psi is equal to closed surface integral vector D dot ds. This implies psi is equal to double integral over the domains of theta and phi. What is vector D? dr into ar cap. What is vector ds? dsr into ar cap. So ar cap dot ar cap is 1. dsr is what? What is dsr? dsr is nothing but r square sin theta d theta d phi, which is the product of dl2 and dl3. So this implies psi is equal to ar cap dot ar cap is 1, dr into r square you take out, theta varies from 0 to pi, phi varies from 0 to 2 pi, sin theta d theta d phi. So this implies psi is equal to dr into r square. Sin theta, if you integrate, you get minus cos theta between 0 and pi. D phi, if you integrate, you get phi between 0 and 2 pi. So this implies psi is equal to dr into 4 pi r square. This implies dr is equal to psi divided by 4 pi r square. What is psi from step number 1? It is rho v into 4 pi by 3 r cube divided by 4 pi r square. So this works out to be rho v into r divided by 3. So many coulombs per meter square. Very involved problem. Hence, vector D is equal to dr into ar cap. What is dr? dr is rho v into r divided by 3 into ar cap. So many coulombs per meter square. Step number 3. To find vector E at point P. At point P. What is, we know that vector D is equal to epsilon into vector E. This implies vector E is equal to vector D divided by epsilon. So it is rho v into r, vector D expression is substitute, rho v into r divided by 3 epsilon into ar cap volts per meter. Fourth step, to find energy stored within the sphere. Energy stored within the sphere. Within the sphere means inside the sphere. Wi is equal, I means inside, half into volume integral vector d dot E dv is equal to half into volume integral. What is vector D? Vector D is rho v into r divided by 3 ar cap dot. What is vector E? Rho v into r by 3 epsilon into ar cap dv. Ar cap dot ar cap is 1. Ar cap dot ar cap is 1. This implies Wi is equal to 1 by 3 into 1 by 3 is 9. 9 into 2 is 18. So 18 epsilon rho v square I will take out. Volume integral is triple integral. R varies from 0 to a. Theta varies from 0 to pi. Theta varies from 0 to pi. Phi varies from 0 to 2 pi. Okay, R into R is R square. What is dV? dV is R square sine theta dr d theta d phi. Now we have to perform the integration. This implies Wi is equal to rho v square divided by 18 epsilon r square into r square r to the power 4. If you integrate, you get r to the power 5 by 5 between 0 and a. Sin theta, if you integrate, you get minus cos theta between 0 and pi. d phi, if you integrate, you get phi between 0 and 2 pi. This implies Wi is equal to rho v square divided by 18 epsilon into a to the power 5 by 5 into 2 into 2 pi. This implies Wi is equal to rho v square 4 pi rho v square a to the power 5 divided by 90 epsilon. So many joules. So this is the energy stored inside the sphere. Hence, energy stored, hence total energy stored is W is equal to Wi plus W naught. We substitute the expressions for Wi and W naught and keep the answer. Thank you. Next problem. Find the energy stored in a coaxial cable, per unit length, solution. First, let us understand what is a coaxial cable. We have got two coaxial cylinders. A length is cut. Right, this is the axis. This is the axis of the cable, which is the z-axis. There are two cylinders which have the same axis, which is z-axis. The inner cylinder has got a radius equal to A. Outer cylinder has got a radius equal to B. We have taken 1 meter length of the cable. Cable has got an infinite length. We have taken only 1 meter length. Therefore, Z varies from 0 to 1 meter. This is 1 meter length of the cable. Now, we connect a battery of potential V0 volts between the two cylinders. How the current flows? Let us assume that here I have connected a load. Let us say this is some load. Correct? The current flows into the load through the inner conductor. Correct? Then it goes to ground. Ground means through the outer conductor it goes back to the supply. Current leaving the supply is I. Current getting back into the system is I. So this is how a cable works. From the source, the load, inner conductor connects. The inner conductor allows the current I to flow from the source to the load. It is like a two-wire system. See, we have got a two-wire system. This is the inner conductor which connects the source and the load. This is the outer conductor which connects the load with the source. So what I mean to say is, what current leaves the source has to enter the source. To the inner conductor, the current I goes to the load. To the outer conductor, it goes back to the supply. This is how a coaxial cable works. The space between the two cylinders, coaxial cylinders, is filled with some dielectric material whose permittivity is epsilon. There is some insulating material between the two coaxial cylinders. The inner cylinder is positively charged, the outer cylinder is negatively charged. The inner one is positively charged and the outer one is negatively charged. Let Q be the charge per unit length. Let Q be the charge per unit length. Therefore, the inner conductor carries a charge of plus Q. Outer conductor carries a charge of minus Q. Correct? There is no electric field for rho less than A. This is in a cylindrical system. When rho is less than A, there is no electric field intensity. When rho is greater than B, what is the net charge enclosed? Plus Q minus Q, 0. Only when rho varies from A to B, you will have electric field intensity. Very, very important. I will construct a Gaussian surface, which is a cylinder. This is a Gaussian surface, which is a cylinder of radius equal to rho and length equal to 1 meter. P is the point on the Gaussian surface. This is vector D. Vector D is what? D rho into A rho cap. D rho into A rho cap. Correct? So Gaussian surface is a cylinder of radius equal to rho and length equal to 1 meter. So I will say construct a Gaussian surface which is a cylinder of radius equal to rho and length equal to length equal to 1 meter. Radius rho meters and length equal to 1 meter. These are the sample flux lines that are coming out of the Gaussian surface. Again, we'll go through 4 basic steps. Step number 1. According to Gauss law, what is psi? Psi is equal to charge enclosed. What is charge enclosed? Q. Because Q is the charge per unit length. Instead of taking 1 meter, if you take L meters, it will be Q into L. So many coulombs. Second step, to find vector D at point P. To find vector D at point P. We know that psi is equal to closed surface integral vector D dot ds. This implies psi is equal to, this is double integral. What is vector D? D rho into A rho cap. What is vector ds? Ds rho into A rho cap. For a cylindrical coordinate system, what is dl1? D rho. What is dl2? Rho into d phi. What is dl3? Dz. Therefore, what is ds rho? Ds rho is what? dl2 into dl3, which is rho d phi dz. This implies psi is equal to double integral over the domains of phi and z. Phi varies from 0 to 2 pi, z varies from 0 to 1, d rho. A rho cap dot a rho cap is 1, dl2 into dl3 is rho into d phi into dz. So this implies psi is equal to d rho into rho is a constant. D phi if you integrate you get phi, which is 0 and 2 pi. Dz if you integrate you get z between 0 and 1. So you get psi is equal to d rho into 2 pi rho into 1. What is surface area of a cylinder? 2 pi rho into h. H is what here? 1 meter. Okay. So this implies d rho is equal to psi divided by 2 pi rho. Please note that one thing I want to tell you. Coulombs per meter square. Just note. I skipped one step. You should understand this. Closed surface integral vector d dot ds is equal to integral d dot ds for the left face means this one, plus integral d dot ds for the top face plus integral d dot ds for the cylindrical face or cylindrical surface. So what is important is the closed surface integral is made up of 3 open integrals. Here S refers to the area of the Gaussian cylinder, which is shown red in color. So please note that. These two integrals are 0. Why? Because vector D is tangential to the left face and the right face. These two integrals are 0. The first two integrals are 0 because vector D is tangential to left and right faces. Actually, this integral is shown here. So this integral is nothing but this. These two integrals are 0. I had skipped one step that I made very clear. So closed surface integral is made up of 3 open integrals. One for left face, one for top face, right face, not top face, right face. and one for cylindrical face. Okay. So these two integrals are 0 because vector D is tangential to left face and the right face. So only this integral will survive, and this integral is evaluated here. What is vector D? D rho into A rho cap. Correct? And what is vector ds? Ds rho into A rho cap. A rho cap dot A rho cap is 1. And what is ds rho? Rho into d phi into dz. So if you evaluate this integral, you get d rho into 2 pi rho into 1, which gives surface area of a cylinder. The cylinder has got radius equal to rho and length equal to 1. Very, very important. So this area is nothing but the surface area of the cylinder shown in the red color, which is nothing but the Gaussian surface. This is nothing but the Gaussian surface. Very important. I hope the concept is clear. So this is the expression for d rho. Hence, vector D is equal to d rho into A rho cap is equal to psi divided by 2 pi rho into A rho cap. From step number 1, what is psi? Psi is nothing but q. Q divided by 2 pi rho into A rho cap. What unit? Coulombs per meter square. This is the expression for vector D at point P. Each problem looks like a derivation. You have to practice it. Please keep it in mind. Step number 3. To find vector E at point P. Vector E is equal to vector D divided by epsilon is equal to Q divided by 2 pi epsilon into rho into A rho cap. So many volts per meter. So please note that for rho less than A, there is no electric field. For rho greater than B, there is no electric field. For rho less than A, charge enclosed is 0. For rho greater than B, what is charge enclosed? Plus Q minus Q 0. No charge enclosed. Charge is enclosed only for rho varying from A to B. Please keep this in mind. Next step, to find W. What is W? Energy stored. What is the formula? W is equal to half into volume integral vector D dot E dV is equal to half into volume integral is a triple integral. Rho varies from A to B. Phi varies from 0 to 2 pi. Z varies from 0 to 1. To take dot product of vector D and vector E. A rho cap dot A rho cap is A rho cap dot A rho cap is 1. Q into Q is what? Q square. Q square divided by 2 pi into 2 pi is 2 pi whole square. 2 pi whole square epsilon into rho square. Vector D is given here. Vector E is given. Take dot product. A rho cap dot A rho cap is 1. Q into Q is Q square. 2 pi into 2 pi is 2 pi whole square. Rho into rho is rho square epsilon. What is dV? dl1, dl2, dl3. So it is what? d rho, rho d phi, dz. This is the expression. This implies W is equal to Q square divided by 2 square is what? 4. 4 into 2 is 8. 8 pi square epsilon rho varies from A to B, phi varies from 0 to 2 pi, z varies from 0 to 1. Rho by rho square is what? 1 by rho. So you get d rho divided by rho into d phi into dz. So this equals Q square divided by 8 pi square epsilon. This becomes what? D rho by rho is what? If you integrate 1 by rho, you get log rho between A and B. D phi, if you integrate phi, put limits, you get 2 pi. Dz, if you integrate, you get z, put limits, you get 1. So this is q square divided by 8 pi square epsilon. Natural logarithm of b minus natural logarithm of a is log of b by a. Natural logarithm of b by a into 2 pi. So this becomes q square divided by, this is 2 by 8 is 1 by 4. Pi cancels out. So you get 4 pi epsilon. Natural logarithm of b by a. 2 pi by 8 pi square is 1 by 4 pi. What is the unit of this? Joules per meter. Means 1 meter length of the cable has got this much energy stored. Therefore the unit is joules per meter. Q square by 4 pi epsilon natural logarithm of b by a. This is the answer. Thank you. We'll go to next problem. Determine the energy stored in two concentric spheres of radii A and B with B greater than A. Concentric spheres of radii A and B with B greater than A. Solution. Actually, the spheres are conducting spheres. Charges reside only on the surface of the spheres. Please keep in mind. So we have got two spheres, concentric spheres of radii A and B. Inner sphere is positive. Okay, what we do is we connect a battery of potential V0 volts between the two spheres. The outer sphere is grounded. Therefore, this battery of V0 volts appears between the two spheres. Since positive terminal is connected to inner sphere, it is positively charged. Since negative terminal is connected to the outer sphere, it is negatively charged. Very important. Now, between these two spheres, we have got an insulating material with permittivity epsilon. For r less than a, r is the radius of the Gaussian sphere. There is no charge because no charge. For r less than a, charge enclosed is 0. Therefore, there is no electric field intensity for r less than a. For r greater than b, if you draw a Gaussian sphere of radius greater than b, charge enclosed will be plus q minus q equal to 0. Therefore, there is no field for r greater than b. Field exists only for r varying from a to b. So, I have taken a Gaussian sphere of radius equal to r between the two spheres. This is the point of interest. If you keep 1 coulomb charge, it will be repelled. What is vector d? dr into r cap. If you keep 1 coulomb charge, inner sphere will repel it, outer sphere will attract it. Therefore, it will move in the radial direction. The direction of electric field intensity and direction of vector d are same. Therefore, vector d is the radial direction. These are the sample flux lines that are coming out of the Gaussian sphere. The dotted one is gs. Gs means Gaussian surface, which is a sphere of radius equal to r meters. Construct a Gaussian surface which is a sphere of radius equal to r meters. Step number 1. According to Gauss law, electric flux psi is equal to charge enclosed. Charge enclosed is plus q coulombs. Second step, to find vector d at point P. To find vector d at point P, we know that psi is equal to closed surface integral vector d dot ds. This implies psi is equal to double integral over the domains of theta and phi. What is vector d? dr into ar cap. Whatever unit vector d has, same unit vector ds must also have. So vector ds is what? dsr into ar cap. dsr is dl2 into dl3. ar cap dot ar cap is 1. This implies psi is equal to dr theta varying from 0 to pi, phi varying from 0 to 2 pi. What is DSR? R square sine theta d theta d phi. This implies psi is equal to dr into r square. Sine theta, if you integrate, you get minus cos theta 0 to pi. D phi, if you integrate, you get phi between 0 and 2 pi. So this implies psi is equal to dr into 4 pi r square. What is 4 pi r square? Surface area of the dotted sphere, called Gaussian surface. Called Gaussian surface. So this implies dr is equal to psi divided by 4 pi r square. What is psi from step number 1? Q. Q divided by 4 pi r square. So many coulombs per meter square. Hence, vector D is equal to dr into ar cap is equal to Q by 4 pi r square ar cap. So many coulombs per meter square. Third step, to find vector E at point P. Vector E is equal to vector D by epsilon. This is the expression for vector D. Substitute. You get Q by 4 pi epsilon r square into ar cap. So many volts per meter. This is the expression for vector E. Fourth step. Fourth step, to find energy stored. That means to find what is W. W stands for energy stored in the system. W is equal to half into volume integral vector D dot E dV. Here V is the volume that contains electric field. I again reiterate, electric field is present only in this region. There is no electric field for R less than A, means in this region. There is no electric field for R greater than B. For R greater than B, net charge enclosed will be plus Q minus Q equal to 0. For R less than A, net charge enclosed will be 0. What I mean is, if you draw this dotted sphere over here, for R less than A, no charge enclosed. If you draw this dotted sphere outside this spherical system, then again charge enclosed will be 0. So what is this volume integral? Volume integral is a triple integral. So this becomes W is equal to half into R varying from A to B. Theta varies from 0 to pi. Phi varies from 0 to 2 pi. Vector D dot vector E, take dot product of these two. Q into Q is what? Q square. AR cap dot AR cap is 1. So 4 into 4 is 16. Pi into pi is pi square. Pi square epsilon. R square into R square gives you R to the power 4. This is the dot product of D and D. Q square, 4 into 4, 16. Pi into pi square epsilon R to the power 4. What is dV? dV is R square sine theta dr d theta d phi. Equals Q square divided by 16 into 2 is 32. 32 pi square epsilon R square divided by R to the power 4 is 1 by R square. If you integrate, you get minus 1 by R. Put the limits A to B. Sin theta, if you integrate, you get minus cos theta, limits 0 to pi. D phi, if you integrate, you get phi between 0 and 2 pi. Equals Q square divided by 32 pi square epsilon. Put limits, you get 1 by A minus 1 by B into 2 into 2 pi. So this becomes now Q square. 2 into 2 is 4 by 32. This is 8 pi. 4 pi divided by 32 pi square is 8 pi. 8 pi epsilon B minus A divided by AB. So many joules. This is the answer. Okay, this is the end of the solution. I hope it is clear. Q square 4 by 32. Thank you.